So it occurs to me that I actually have things written out of order. This should be the next property, and that's the one that this video will be devoted to. In fact, the other property up here is, I think, quite easy to prove, so I'm actually going to leave it to you to prove it to yourself, or to read the proof here, whichever you prefer, but I'm just going to make a video on this one and move on with the rest of the book in the future videos. So, even this one, I think most of its properties are relatively easy to prove. I think transitivity is pretty easy, so are the linear properties. The only one that strikes me as somewhat not obvious is the fact that this union over a set of ordinals must have a every non-empty subset must have a least element. And at least what I had in mind, which gave me pause, was what if this set X is a set of very large ordinals, always descending in value, and so does not seem to have a least element. Well, in retrospect, that doesn't mean that every non-empty subset doesn't have a least element, but it's at least worth it to me to go ahead and flesh out exactly how that proof looks. So here it is. Suppose that we have A, some non-empty subset of the union. Then it must have some element. That means that it came out of some element in X, right? X must have something that little a came out of, call that element alpha. Then by selection of alpha, then little a is in alpha. Okay, now we can get a least element, at least out of the intersection of A with alpha, because that is a non-empty subset of alpha. After all, these both have A in them, little a in them. Alpha being a well-ordered set, therefore has a minimum, call that gamma. Now, I claim that gamma is also a minimum for A, big A. How do I know? Well, suppose for contradiction otherwise. There is this B in gamma, such that B is less than, or sorry, B in A, such that B is less than gamma. Well, I can chain together the less thans and get that B is less than alpha. Well, this just means that B is in alpha, and therefore it is in both A and alpha, therefore it's in the intersection. Well, this tells me that, in fact, an element of the intersection, B, was less than the least element, a contradiction. That's what I should have written here. And therefore, we have that for all choices of B, that gamma is less than or equal to it. Therefore, it is a the least element of A. This tells me that every non-empty subset of the union has a least element, and I'm done.